Hi Austin. Here are some more directions on how to work out problem number 12 and homework number 2. Or at least the first part, because like you said in your email, if you can do the first part, then you can easily apply the same method to the other parts. So what we're asked is to find the volume of the solid generated by revolving the region bounded by the parabola y equals negative x squared over 16. And the line y equals negative 1 about the following lines. And in part A, it wants us to go about y equals negative 1. So the first thing you need to do is draw your two-dimensional region, which is bounded by those two graphs. So y equals negative 16 or negative x squared over 16 is a really wide upside down parabola. And then y equals negative 1 is, we'll say there. So this is the region we're talking about in part A. We also want to revolve this around y equals negative 1. So to draw that solid, the first thing you do is you reflect your graph and then just give it some little arcs to make it look like it's got circular cross sections. So that's what we're looking at. But the important thing to remember is that the original piece that we drew is right here. That's going to be really important. So because we have a horizontal axis of revolution, you should use the disk method. And I suggest you set this up just like a normal disk method problem, like you're revolving around the x-axis. So if you draw a line through your region towards your axis, when we do the disk method, and this is actually, even though we don't see a hole in the middle, it's really going to be the washer method. The trick with the washer method is almost always there's going to be a hole in the middle of your volume, but the surefire way to know that you need to use the washer method is that the x-axis is not a bound of your region. So since the x-axis is not a bound of my region, I'm going to have to do, my other bounds are actual functions, so I'm going to have to do the difference of those functions squared. To decide which one to write first, you always draw a line that goes through your region and points towards your axis of revolution. And the function that it hits first is going to be the one that you write first in your integral. And then the function it hits second, you're going to write second. So this vertical line that I drew that points down, it goes through the parabola first. And then it hits my y equals negative 1 line second. So if I set this up just like a normal disk method problem, it would be pi integral of the outer, which is negative x squared over 16 squared, minus the inner squared, and that's the one that it hit second, so negative 1 squared dx. And this region, if you look and see what those intersections are, those will be our bounds for the region. Since we weren't given a region or an interval to work on, those intersection points are when your functions are equal. So we're looking to see where negative x squared over 16 equals negative 1. If you multiply negative 16 over, you get x squared equals positive 16. And then you square root both sides and get x equals plus or minus 4. So those are going to be our bounds. So this is what it would look like if it was being revolved around the x-axis. But we are actually revolving around a different axis. So the only thing we need to adjust is we need to take our current axis of revolution, which is y equals -1, and we need to shift it so that it lines up with the x-axis. So if you look of where y -1 is and where x is, in order for them to line up, I would have to move y equals -1 up 1 unit. And I'm allowed to do that as long as I do it to everything. So this current axis of revolution needs to be moved up 1 to line up with the x-axis. So what I do is just come in here and say +1. That will shift it up 1. And +1. It will shift it up 1. So the actual integral that we need to calculate is pi, integral from -4 to 4, of -x² over 16 plus 1 squared. And then -1 plus 1 is 0. Square that at 0, subtract it, it doesn't do anything. So this is all we've got in our integrand, is the -x² over 16 plus 1 quantity squared. So this is what we actually want to compute so we can find our volume. So if you're going to do this by hand, we're going to have to write that expression in the parentheses twice and FOIL it out. And that's what the squared means. So we got -x² over 16 plus 1 times -x² over 16 plus 1. And we're going to FOIL it. So for the very first one, negative times a negative is a positive. X² times x² is going to be x to the 4th. And then 16 times 16 is going to be 256. So that was this part. And now we want to multiply it by +1, and that will just give us back what we started with. And then if we do the inners, we get -x² over 16, and then we have 1 times 1, which is 1. So right here, I've got fractions with the same denominator, which means I can combine them. So I've got a -1 of them, and a -1 of them is going to make a -2 of them. But then you'll have a common factor that you can cancel. If you've got -2x² over 16, the 2 and the 16 can simplify to just an 8 in the bottom. And in this form, we can just apply the power rule to everything. So we've got x to the 4th over 256 minus x² over 8 plus 1 dx. So the power rule says that this is going to be, so the old power of 4 is going to go up to a 5, and then we need to divide by 5. Since we're already dividing by something else, we just multiply them together. And we get 1,280. Same thing here, the old powers of 2 is going to go up to a 3. And then you divide by 3, which when we multiply that with the 8 gives us a 24. And then we have plus x. And we're going to evaluate from -4 to 4. So now if we plug 4 in, 4 to the 5th is 1,024. And I'm just going to go ahead and divide that by my 1280 and simplify it as much as possible. And it comes out to be 4/5. And then 4 cubed is 64. And divide that by 24. And write it as just a simplified fraction. We get -8/3. And then plus 4. And then we want to know what we get when we plug in -4. Well, we're going to get all the same things but with opposite signs. Because a negative to an odd power is going to stay a negative. Where in when we plug +4 in, it was all positive. So we're going to be subtracting -4/5 plus 8/3 minus 4. And that's got a pi as well. And then we just need to get all these fractions together. And you could just do this in your calculator, but when I do this, we end up with 64 pi over 15. So most likely, if you went wrong anywhere in here, it was really probably having to do with the fact that we've got this axis of revolution other than the x-axis. So if it's a horizontal axis of revolution and you're going to do the disk method, the way that you fix this is by just shifting everything so that the axis of revolution that you're asked to do lines up with the x-axis. So your part B says to use the same exact region but revolve it around y equals 2, or excuse me, negative 2. So if we were doing y equals negative 2, I'm not going to draw the new solid, but if we're revolving around y equals negative 2, what we'd want to do is shift everything up 2 units. Both of the functions will then easily work out with the disk method. And then in part C, it says go around y equals 1. So in order to shift y equals 1 to the x-axis, we've got to go down 1. So we would minus 1 from everything.